Okay, so let's do another example. This example is going to be a little bit long, but it solves a completely full problem with the initial values. Okay, all right. What we're going to do first is let's take the homogeneous version of the differential equation. Okay, now let's write the auxiliary equation. This will be m square minus 3m minus 4 is equal to 0. Now if you factorize this, what we get is m minus 4 m plus 1, right? Okay, yes. So then the roots are m1 is negative 1, m2 is 4. So it doesn't matter, the order doesn't matter. Okay, all right. Now what is the fundamental set of solutions? E to the negative x and e to the 4x. Then the complementary solution is c1 e to the negative x plus c2 e to the 4x. So that's the solution for the homogeneous version of the differential equation, but we will need it once we need to find the general solution at the end. Okay, all right. Now let's go to the particular solution. So we need to make a guess. What will be our guess? So our right hand side is 2 sine x, constant times sine. So our guess will be a cosine x plus b sine x, right? Because usually a trigonometric function both have sine and cosine, right? Now what is the next step? Check for overlap. Do we have an overlap? These are sine, cosine, these are exponential functions. No overlap at all, right? Okay. Then the next step is find y prime, find y double prime, and substitute them back to the non-homogeneous differential equation. So let's take the derivative. So y prime here will be derivative of cosine is negative sine, so negative a sine x. Derivative of sine is cosine, so b cosine x. Second derivative is if you differentiate sine you get cosine, negative a cosine x. If you differentiate cosine you get negative sine, b sine x. Okay, so now substitute these three into the differential equation. So let's do that. So y double prime negative a cosine x minus b sine x minus 3 times y prime is negative a sine x plus b cosine x minus 4 times y is a cosine x plus b sine x is equal to 2 sine x. Okay, that's a long one. Now the next step is simplify your left hand side. Try to add terms, try to cancel terms, and regroup the terms. So if you expand all the brackets, so negative a cosine x, negative b sine x. Here if you multiply by negative 3, this will be 3a sine x minus 3b cosine x minus 4a cosine x minus 4b sine x. Okay, you have to be very careful here. Okay, you can do mistakes when you're simplifying, when you're trying to find the coefficient. This is a very important step. All right, okay. Now let's see the similar terms. So negative a cosine x, let's look at the cosine terms. Negative a cosine x, negative 3b cosine x, negative 4a cosine x. Negative 4a cosine x and negative a cosine x and negative 4 cosine x together is negative 5a cosine x and minus 3b cosine x. Well, we cannot combine these two, right? Because we have a and b different, but we were able to combine these two. Now then the sine terms, negative b sine x and 3a sine x, negative 4b sine x. So negative b and negative 4b, negative 5b sine x plus 3a sine x, okay, is equal to 2 sine x. Good. All right. So here we can factor out a cosine. So negative 5a minus 3b cosine. Here we can factor out a sine plus negative 5b plus 3a sine x is equal to 2 sine x. Okay, so we shrink this large left hand side into simpler terms now. All right. Now what is the next step? Well, we need to find this a and b. We have the simplest grouped organized version of the left hand side, right? Well, let's match the coefficients. So sine coefficient should be matched with sine coefficients. So negative 5b plus 3a should be 2, right? Because here you have 2, here you have this term. And do you have cosine terms on the right? No, right? So 0 and 0 should match up with coefficients of the cosine on the left hand side. Okay, so we get two equations, equation 1, equation 2. So this is not straightforward as example 1, right? Okay, so how do we solve a equation 1 and equation 2? Well, let's try to solve for a. We have 3a, we have negative 5a. So let's try to make their coefficient 3 and negative 5 the same. So let's multiply the equation y by the number 5. Okay, and let's multiply the equation 2 by number 3. Okay, so if you multiply the first equation by 5, you get negative 25b plus 15a is equal to 2 times 5 is 10. Now if you multiply the equation 2 by 3, negative 15a minus 9b is equal to 0. If you multiply by 3, 3 times 0 is 0. So let's call this equation 3, let's call this equation 4. Now why I did that? Because I get same number in for a but different sign. So we can add equation 3 and 4. We get a magic, right? If you add equation 3 and 4, negative 25b plus negative 9b is negative 34b on the left. Now negative 15 plus 15 gone. So a will be gone. So that is why we need the same number but opposite sign. Equal to 10 plus 0 is 10. So what is b? Well, b is little bit of ugly number. 10 over 34 is 5 over 70, negative. So b is negative 5 over 70. Okay, alright, so let's find a. Well, to find a, we can use any of these equations. So we know now b, so negative 5 times negative 5 over 17 plus 3a is equal to 2 if you use the equation 1. So this will be negative 25 over 17 plus 3a is equal to 2. So let's take this term to the right. So 3a is equal to 2 plus 25 over 17. So 3a is, if you take the common denominator and simplify, well, we get a rather large number. 734 plus 25 is 59. 59 over 17. So our a, did I do a mistake? Well, let's stick with this. Okay, so if I have made a mistake, so be it. So a is, so 59 over 17, if you divide by 3, well, 59 over 17 times 3 is 51. Okay, a is rather a large number. So I might have done a mistake somewhere. Oh yeah, I have done a mistake. They should be plus 25. So you'd be subtracting. Okay, that's the mistake. Negative 5 times 5 is positive. Okay, so this will be not so large. If you simplify this, you get 9 over 17, which is a is, if you divide by 3, it's 3 over 17. Okay, so we know a, we know b. We can now write the particular solution. Particular solution was, guess was a cosine x plus b sine x. So it is a is 3 over 17, 3 over 17 cosine x minus b is negative 5 over 17, negative 5 over 17 sine x. So this is y sub p. Now what is the general solution? So the general solution is complementary function. Complementary solution is c1 e to the negative x, c2 e to the 4x. c1 e to the negative x plus c2 e to the 4x plus 3 over 17 plus particular solution minus 5 over 17 sine x. Okay, so this is the general solution for the non-homogeneous problem. Now notice, particular solution, now you don't have parameters a and b. So that is why we call it particular solution. But the complementary function part still have c1 and c2. We can't find them unless they give us an initial condition. So the initial condition given here is y0 0 and y prime 0 is 1. So let's use them. y0 0 and y prime 0 is equal to 1. So if you use the first condition, if you substitute 0 for x, y should be 0. So e to the 0 is 1, so c1 plus c2. Cosine 0 is 1, sine 0 is 0, so plus 3 over 17 times 1 is 1. Okay, so that is done. So c1 plus c2 seems to be like negative 3 over 17. Okay, so that's c1 plus c2. We get a 1 equation. Now we need to use the other initial condition, but that other initial condition is for y prime. So we have to find the y prime here. Okay, so this is a rather long question, right? So if you differentiate with this with respect to x, you get negative c1 e to the negative x plus 4c2 e to the 4x. Cosine derivative is negative sine negative 3 over 17 sine x plus minus derivative of sine is cosine minus 5 over cosine x. So this is the derivative y prime. Now we can use x0, y is 1. So y is 1 when x is equal to 0. So here negative c1 e to the 0 is 1 plus 4c2 e to the 0 is 1. Sine 0 is 0, cosine 0 is 1, so negative 5 over 17. So we get negative c1 plus 4c2 is, if we take this term to the right, it will become 1 plus 5 over 17. So it's 22 over 17. So we get two equations, right? Wow, this is very long, right? So c1 plus c2 is negative 3 over 17. So we get two equations. Now we want to solve these two equations for c1 and c2. Let's call this 1, let's call this 2. So now c1 coefficient is 1 but opposite sign. So let's add first two equations. So if you add the first two equations, c1 cancel out. 4c2 plus c2 is 5c2. If you add 22 over 17 minus 3 over 17 is 19 over 17. So if you divide by 5, c2 is 19 over 17 times 5 is 85. So c2 is this. Now to find c1, we can use the second equation. c1 plus 19 over 85 is negative 3 over 17. So then c1 is negative 3 over 17 minus 19 over 85. So c1 will be negative 34 over 85. Okay, so I simplified that fast. Okay, so now we know c1 and c2 both. So the final solution will be c1 negative 34 85 e to the negative x. c2, what was c2? c2 is 19 over 85. So 19 over 85 e to the 4x. And then the other part's particular solution in the here is 3 over 17 cosine x plus 3 over 17 cosine x minus 5 over 17 sine x. 5 over 17 sine x. This is the general solution for the differential equation for the initial value problem. Rather a long one, but it is what it is. Okay. All right. Okay. Thank you.